Assalamualaikum warahmatullahi wabarakatuh. And very good morning to my beloved lecturer, Madam Dr. Nurhaliza binti Abu Bakar. Today, we are Group 5 will present the problem-based learning PBL that our group has completed. Before I start the presentation, I would like to introduce the group member first. So this group consists of 4 members, which is Abdul Yafi Hazwan bin Abdul Rahman, Aminuddin bin Jamaluddin, Adam Ifan bin Muhammad Usli, and lastly is me, Wafa Nurdana binti Abdullah. Let's start our presentation with introduction. As we know, each group is given 2 questions that need to be solved. One question related to population and another question related to Newton's law. What is population? Population is the total group from which a sample is taken. So the question our group get is population growth, P. So when population growth, P is the size of the population at the time. So the formula we can use to find population growth is Kp equal to dP per dt, or P times T equal to PO times e power of Kt. For the second question, our group get question related to Newton's law. Isaac Newton, a British physicist, researched cooling of body in the late 17th century. Experiment revealed that the cooling rate is proportional to the temperature differential between the heat body and the surrounding. This fact is denoted by the differential relationship dq per dt equal to lambda A times with bracket Ts minus T. In the slide, that is first equation. When Q is the heat, A is the body surface area through which the heat is transferred, T is the body temperature, Ts is the surrounding environment temperature, and is the heat transfer coefficient, which variance depends on body geometry, state of surface, heat transfer mode, and other factors. We know that Q equal to Ct, where C represents the body heat capacity, so that we may write dT per dt equal to lambda A per C times with bracket Ts minus T equal to K times bracket Ts minus T. In slide, that is second equation. Then we can summarize that T times T equal to Ts plus bracket To minus Ts times e power of minus Kt. In slide, that is third equation. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Now I will explain about Pbl table for both question, which is A6 and B2. The facts from the question A6 is in the year of 1999, total population in town A is 59,763. In the year of 2009, total population in town A is 62,763. That means the longer the year, the greater the population. The ideas from this question is the desire to make that there is no limit for child production in town A, and maybe town A is so attractive that many people are interested to continue to live there. The main issues from this question is what is the total population of town A over a period of 10 years from year 1999 to 2009. Does the population in town A increase? And would the population still increase in the year of 2019? And last one is, the population is still increasing in 2019. What is the expected total population for that year in town A? Okay, let's move to the next question, which is B3. From this question, the facts that I found is, I had my auntie with her catering business in the holiday session. When I want to serve soup, auntie told me to cook the soup first at room temperature. Therefore, after 6 minutes, the soup was left at room temperature. The soup had changed from 82 degree to 50 degree. The ideas from this question is, I want to feel is very hot soup is not suitable to be served to guests. Maybe because the relatively cold room ambient temperature compared to the soup has made the soup cool quickly. And learning issues. And learning issues from B3 question is, when the soup is left at room temperature, can the soup be cooked? What is the appropriate room temperature for cooling the soup? If the temperature of the soup is 80, 82, 82 degree, how long does it take for the soup to change to the temperature of 50 degree at room temperature? That's all from me. Thank you.
Assalamualaikum and hi, my name is Abdul Rafiq Azwan bin Abdul Rahman, and today I will be explaining to you about the solution of our problems. So this is the question that we solve, and as you can see, the question provides us with the total population in year 1999 and in year 2009. Assuming that the population is increasing at a rate of proportional to its size at any time, the question asks that estimate the population in 2019 and giving the answer to the nearest 100. So this is the solution on how to solve the question earlier. We use the formula Pt equal to P0 exponent to the power of kt. Bear in mind that P represents population and T represents the duration between years, and K is a constant. So we started P0. What is P0? If we set T equal to 0 in the year 1999, so P0 equal to 59,763, which is the population in the year 1999. Next is P10. Same as earlier, we set T equal to 10 in the year 2009. So P10 is 62,763, which is the population in the year 2009. Next, we substitute all the information that we obtained into the formula that I mentioned earlier. So we get this equation. To solve for k, we apply the logarithm to both sides to get ln 62,763 equal to ln 59,763 plus ln exponent to the power of 10k. And then we solve this equation, and then we obtain k equal to 0.0049. Now that we have k, and then we can proceed to answer the question, which is to find the population in 2019. By using the same formula that I mentioned earlier, we substitute K equal to 0.0049, and then the population that we obtain is 65,916.37. This is already rounded off to the nearest hundred. Next is question 3 by Newton's law of cooling. The question stated that during the holiday season, you help your auntie with her catering business. Before you can serve soup to the guests, your auntie asks you to cool down the soup first. The rate at which a container of hot soup cools down is proportional at that instant to the room temperature. A container of hot soup is placed in a room temperature of 18 degrees Celsius, and in 6 minutes, the solution cools from 82 degrees Celsius to 50 degrees Celsius. Determine the length of time, T, taken for the solution to cool from 30 degrees Celsius to 22 degrees Celsius. Next, we substitute all the information that is stated in the question into this formula. The question stated that the room temperature is 18 degrees Celsius, and we use the rate of soup to cool down, which is from 30 degrees Celsius into 22 degrees Celsius. We minus 30 with 22 and divided by time, equal to 16/3, and we use cross multiplication method to find T, which is equal to 4 minutes. 4 minutes is the final answer. That's all for me. Thank you.
For the conclusion, based on the question that we have solved together, we can identify that there are two major titles, namely population and Newton's law. A population in this study does not have to be a specific group of individual. It is the whole group from which is a sample is drawn. The score of all students in a certain high school in a given year, for example, might be characterized as population. Differential statistics attempt to forecast or estimate a population parameter using data from trial on a subset or sample of the population of interest. For the first question, we need to find a total population increase in city A in 2019. So we have solved that problem by way of the potential growth of engineering math. Next, we can identify the type of Newton's law that will solve in their issues question based on the problem in the question. For the second question, the question indicates that we need to find the time required for the solution to cool from 32 Celsius to 25 Celsius. From the problem statement in the question, we can identify that is Newton's law of cooling. So we can solve the problem by using differential equation. After all, we can solve the question easily because we can find a keyword and problem in the question. The importance understanding population growth is essential to predicting, managing, monitoring, and disease outbreaks. This is because a common pattern of population growth may be described and simulated using mathematical population model. Other than that, Newton's law of cooling is important in the study of water heating since it tells us how quickly hot water in pipes cool. One practical application is that it can inform us how quickly a water heater cools down if the breaker is turned off when we are on vacation.
So that's all from us, Group 5, and thank you for listening.